Hey guys, this is 𝐻𝐤 from ACM student chapter IIT ISM Dhanbad, and in this problem I'm going to talk about the D problem, Grid-00100 of Codeforces round 654 rated for division 2. So in this problem you are given integers n and k, and we need to construct a grid A with n cross n consisting of integers zeros and ones. The condition is that the sum of all elements in this array should be equal to k. So as it consists only of zeros and ones, the sum of all elements means that the number of ones in the grid should be equal to k. Now let's define a few terms. 𝐴𝐼𝐽 is the integer in the ith row and the jth column. Ri is ai1 plus ai2 plus up to ain, so which means the sum of all the elements in the ith row, and cj means the sum of all the elements in the jth column. So it indirectly means that the number of ones in the ith row and the number of columns in the jth column, because the grid consists only of zeros and ones. Now we are given a function f of a, which is max r minus min r squared plus max c minus min c squared, which is the maximum of r, which is the number of ones in the maximum, and number of ones which is minimum squared, plus the number of ones which is maximum in some column minus the minimum ones in some column squared. So let's look at the test cases for this one. So let's say n equal to 2 and k equal to 2. So the answer for that is this. So the max r is 1 because each row has only one, and max c is also 1, min r is also 1, and min c is also 1. So 1 minus 1 squared plus 1 minus 1 squared, which is 0. For n equal to 3 and k equal to 8, this will be the answer. And in this one, the max r is 3 for row 1 and 2, and min r is 2 for row number 3, and max c is 3 for column number 1 and 3, and min c is 2 for column number 2. So 3 minus 2 squared plus 3 minus 2 squared equal to 2. Now for n equal to 4 and k equal to 16, a 4 cross 4 grid with 16 ones, so we fill the entire grid with ones, and max r, min r, max c and min c all will be equal to 4. So 4 minus 4 squared plus 4 minus 4 squared. So let's look at the constraints for it. So n equal to 300 and k equal to n square. So and the sum of n square does not exceed 10 raised to power 5. So in this question we need to solve it in n square time or maximum n square log n time. So let's analyze the problem a bit. So sum of number of ones in each row is equal to k. So if we take the sum of ones in first row plus sum of columns in second row and sum of columns in third row, all of it, the sum of entire will be equal to k. Similarly for columns. Now as there are n rows, if we try to equally distribute the ones among all rows so that the difference between the maximum and minimum is as least as possible. So for that we distribute k by n, at least k by n ones in each row and at least k by n ones in each column. As there will be some remainder, we add this remainder to some columns. The number of such columns will be k modulus n, and this remainder is the reason that we are getting r max minus r min. As if it gets evenly distributed in k by n rows and columns, then each of the row and column will have k by n ones, and it will be the difference between maximum and minimum will be 0. So we need, in these kinds of problem, we need to see a pattern such that the maximum and minimum are equally distributed. So let's take one such pattern. Let's say n equal to 3. So n equal to 3, let's take a 0 array. Now we start filling ones diagonally, and we do that n times. So we start at 0, 0, and we put a 1 here, put a 1 here. So this is 3 ones. Now as I said, we will do that only n times, and after n times we start from 0, 1. So we start here. Now we put another 1 here, move diagonally, put 1 here, and now as we reach end of bounds, we take modulo and down, and as we reach end of bound we take modulo n and go to the beginning of the array every time. So we go here, we put 1 here. So thus we keep filling the ones in the diagonals n times starting from 0, 0, and after n times we start from the next column. So if we were at 0, 0 and went diagonally n times, we then after n times we start at column 0, 1, then we start 0, 2 and so on, and every time our I or j reaches n, then we take modulo n so it does not go outside the array. So what is so special about this algorithm? So I will write this again. Now observe that after we put each one, max r and min r will differ by at most 1. Similarly, max c and min c will differ by at most 1. So let's take 1 here. Now the max r is 1 for column number 1 and is 0 for 2 and 3. So 1 minus 0 is 1. Similarly for column, max c is 1 and min c is 0. So 1 minus 0 squared plus 1 minus 0 squared, it is 2. Now we put a 1 here. Again it differs by at most 1. We put 1 here, and now each row and each column has only 1 1. So 1 minus 1 squared plus 1 minus 1 squared, which is 0. And we have put 3 1s here. Now we start from 0, 1. Again we put a 1 here. Now the first row has 2 1s while the rest of the rows have only 1 1, and the second column has 2 1s while the rest of the columns only have 1 1. And we move diagonally, we put another 1 here. Now the first 2 rows have 2 1s and the third row has only 1 1, while the second and the third column have 2 1s and the first column only has 1 1s. We move down and next, and as we reach end we go again to the beginning, we put a 1 here. Now this is, we have put 6 1s here and we need to put 8. So we started from 0, 1. Now we went to 0, 1. Sorry, we went to 0, 1 and now we go to 0, 2. Now we place a 1 here, we move down and to the right it is end of bound, so we go to the beginning again, we put a 1 here. Again if you see, the first 2 rows have 3 1s while the third one has only 2, and k equal to 8. So this is our answer, and the f of a will be equal to 3 minus 2 squared plus 3 minus 2 squared, which is 2. Now let's find when k is k modulus n equal to 0, f of a equal to 0. So in the same example, let's take another example. Let's say n equal to 4 and we solve for each of the k's from 0 to 16. So this example is to see that when k modulus n equal to 0, f of a equal to 0, and for rest of it is equal to 2. So now as k equal to 0, n equal to f of a equal to 0. Now we start from 0, 0, put a 1 here. Now f of a is 2 because the max r is 1, min r is 0, max c is 1, min c is 0. We put 1 here, f of a remains 0. We put 1 here. Now for k equal to 4, this will be the grid, and f of a equal to 0 as each row and each column has only 1 1. Now we move to 0, 1, we put 1 here. Next we move diagonally, 1 here, move diagonally, 1 here, move diagonally, and now as it is end of bound, we go to the beginning and put 1 here. So after k equal to 8, each row and each column has 2 1s, so f of a will be equal to 0. Now as we put 1 here, the first row has 3 1s while the third column has 3 1s. So the f of a is 3 minus 2 squared plus 3 minus 2 squared, which is equal to 2. We add 1 here, move out of bound, we move to the beginning, 1 here and 1 here. So after k equal to 12, we again get a 0. For rest of the case it is 2. Again we move to 0, 4, 0, 3, put a 1. Now 1 here, 1 here, and at k equal to 16, we again get a 0. So basically if if k modulus n equal to 0, ans equal to 0, ans equal to 2. So let's look at the code for this. So we input t and then n and k, we initialize the answer array and we initialize it to 0 using memset. Now if k modulus n, which means k modulus n is greater than 0, then cout 2, else cout 0. So this is the answer. Now let's construct our grid. We start at 0, I and n times we move diagonally. So ans x, y equal to 1, and now we move diagonally. To move diagonally, we increment the row by 1 and the column by 1. So as you can see here, this is 0, 0, this is 1, 1. We incremented the row by 1 and column by 1. Similarly, increment row by 1 and column by 1, we get here and we get here. So after I equal to 0, we go to I equal to 1. So the beginning will be 0, 1. So we reach here and we continue the same process, and the out of bound condition that I talked about will be automatically checked in modulo n. So every time it gets equal to n, it will go to 0. We also put a c here. C is the number of ones that we have put here. So when it reaches k, this loop will break, this loop will break, and we will go here. So when c equal to k, we will have put k ones in our array, and then we simply print the array. So as you can see, it is accepted in 31 milliseconds. Thank you for watching the video. Please like, share and subscribe.